For the longest time, the world of data was all about order. Neat rows and columns, like a massive digital filing cabinet. But what happens when your most valuable information just doesn't fit in the drawers anymore? Today, we're going to dig into how data itself is changing and what that means for the very warehouses we built to hold it. So let's kick things off on familiar ground. For decades, data warehouses have had a very specific way of looking at information. What is that traditional worldview exactly? Traditionally, it's a world of perfect, predictable order. I mean, just picture a giant spreadsheet where everything fits perfectly into rows and columns. But today's reality, well, it's a whole lot messier. It's a world just overflowing with documents, complex geographic maps, and all sorts of media files. This slide really captures that fundamental shift we're about to unpack. To really get where we're going, we first have to appreciate where we've been. So let's do a quick recap of the building blocks of that highly organized relational world. Right, so these are the classics. We use star and snowflake schemas to organize our data into facts. Those are the numbers we want to measure, and dimensions, which give those numbers context. This whole structure lets us build what are called n-dimensional cubes. Think of a Rubik's Cube of data, letting us slice and dice sales by region, by product, over time, all at once. The real takeaway here is that this entire system was engineered from the ground up for one thing: highly structured, predictable data. And that brings up the big question. If the old model works so well for what it does, what's forcing this huge change? The answer is a whole new category of information that just refuses to play by the old rules. So what exactly is this complex data? We are right in the middle of a complex data explosion. And this isn't just about more data. We're talking about fundamentally different kinds of data that are now absolutely critical for making smart decisions. Okay, so here's the simplest definition. Complex data is basically anything that breaks that neat spreadsheet model. It can be semi-structured, like an XML file with its own nested hierarchy, or it can be totally unstructured, like, say, the raw text of an email. And this kind of data is absolutely everywhere now. Just think about it, the sheer volume of text in your company's emails and reports, the XML that pretty much powers all data exchange online. We've got geographic data behind every single mapping and logistics service, and of course, massive growing archives of images, audio, and video. All of this stuff is incredibly valuable. So this leads to a pretty major technical roadblock. If all this data is so valuable, why can't we just dump it into our existing warehouses? What's the fundamental problem here? You see, the problem is a total design mismatch. Traditional warehouses are built on rigid schemas. You have to define the entire structure first, but complex data is, by its very nature, fluid and unpredictable. Trying to cram it into a relational model means doing all this crazy complex pre-processing, and even then, you often end up losing crucial context and information along the way. You just can't apply the old algorithms and expect them to work. But hey, where there's a challenge, you're always going to find innovation. So how are engineers extending the data warehouse model to actually embrace this complexity instead of just fighting it? Let's check out a few key solutions. Let's start with geography. How in the world you teach a system that was built for numbers to understand physical space, distance, and location? This is a huge deal for logistics, for retail, for pretty much everything. Well, the answer is a technology called SOLAP, which stands for Spatial Online Analytical Processing. It's basically an extension of those OLAP cubes we already know, but it's been beefed up to handle spatial measures. This lets us analyze geographic information at all different scales, from a single point on a map all the way up to an entire country. So how does it actually work? Well, first, the model represents the spatial data at multiple levels of detail, or granularity. Then, it uses something called coarsening operators to simplify and group that geometry together. The easiest way to think about it is like zooming out on a map. The fine details get smoothed over, but you see the bigger picture. And then, the system can display the results not as a boring table, but as a cool interactive map. All right, next up, the absolutely massive challenge of unstructured text. We're way past just storing documents now. We need to actually understand what's inside them. This slide highlights a real paradigm shift. For years, we've relied on information retrieval, or IR, which is basically a fancy keyword search. It's great at telling you which documents have a certain word in them. But the future is all about information extraction, or IE. This goes so much deeper. It actually reads the text to find entities like people and companies, it figures out the links between them, and it pulls out the actual events being described.
We're making a huge leap from just finding to actually understanding. And for our final case study, let's talk about taming semi-structured data, focusing on XML, which has pretty much become the backbone of how data gets exchanged on the web. See, to handle XML the right way, new models like the XML Document Warehouse or XDW are being created. And unlike the traditional models, the XDW is designed from the get-go to understand and preserve the complex hierarchical nature of XML documents. It captures all those nested relationships in a way that a flat star schema just can't, which allows for much, much richer analysis without destroying the data's original structure. So after all that, what does it all mean? Well, the path forward for data warehousing is becoming crystal clear. It has to get more flexible, more intelligent, and ready to embrace complexity. This quote from the research just nails it. It says, "The combination of OLAP and data mining techniques is a new challenge imposed by complex data." What that really means is it's no longer enough to just report on data. We have to integrate these sophisticated mining techniques right into our warehouses to unlock the value that's hidden deep inside all this new data. And that brings us to the final thought, really. This explosion of complex data, it isn't some trend that's off in the future. It is happening right now. So the real question you have to ask is, are your tools, your strategies, and your architectures evolving fast enough to keep up? Hey, if this deep dive into data architecture was useful for you, please go ahead and hit that like button and subscribe for more explainers on the tech and trends that are shaping our future. Thanks so much for watching.